So, hello everyone again. This is lecture 11 part 3 of semiconductor electronics, materials, devices and simple circuits. In this we will understand, we have completed the logic gates concept. We will just go with the basic understanding of what is integrated circuits. We will do a summary and then we will close this lecture. So, I am Sameer Lavankar. Let us begin our discussion. Okay. So, in the last lecture we have completed with the digital electronics. We understood basically what is a NOT gate. So, just quick revision, what is a NOT gate. So, if the output is 1 you will get the answer as 0, and if the input is 0 you will get the output as 1. What is a OR gate? So, if it is 0 0 0 1 1 0 1 1 you will only get the answer as 1 in every case scenario irrespective of except when both inputs are 0. Then we next understood what is an AND gate. AND gate is again 0 0 0 1 1 0 1 1. So, it is 1 only and only when both of the inputs are 1. Moving on to the next gate, that is NAND gate. NAND gate has an output again 0 0 0 1 1 0 1 1, but only it will just reverse the AND gate operations of the output. And finally, which is NOR gate. NOR gate is again 0 0 0 1 1 0 1 1. So, you will just need to reverse the operations of the OR gate. So, these are the 5 gates which you need to understand. We understood what is the difference between analog signal and digital signal, and that was all about the 10th topic. Moving on, let us understand the 11th, that is integrated circuits, and then we can move forward with the summary. Okay, so, integrated circuits. So, the conventional method of making circuits is to choose components like, so now you know what is a diode, you know what is a transistor, you know what is an resistor, you know what is an inductor, you know what is a capacitor, correct, everything. So, now this is the ending of your class 12th final lecture. So after understanding every concept, we should know everything which is written here. We know what is a diode, what are different types of diodes, what is the application of diodes, again same thing, transistors also application, what is its usage, how can we utilize them, what is a resistor, series, parallel, what is a inductor, self inductance, mutual inductance, what are capacitor, series capacitance, then parallel capacitance, etc. Fine. So, the conventional method of making circuits is to choose components like diodes, transistors, R, L, C, etc., and connect them by soldering wires in the desired manner. Fine. In spite of the miniaturization introduced by the discovery of transistors, such circuit was still bulky. Okay, so, even if we try to what we can say decrease the size of transistors, but these all components such as diodes, R, resistor, inductor were itself so big that the complete circuit form was very bulky, bulky as in high in weight. Apart from this, such circuits were less reliable and less shock proof. So, as in they were less reliable and they were less shock proof also. The concept of fabricating an entire circuit, please understand this line very carefully. The concept of fabricating as in manufacturing or making an entire circuit which consists of many passive components. Now, what are these components? There are components like resistor, capacitor and active devices like diodes and transistors on a single block, That single block can be also called as chips. On a single block or chip of a semiconductor has revolutionized the electronics technology. Such a circuit is called as integrated circuit. Okay. So, if in layman language, what is the basic understanding, that everything which we have understood in the class 11 and class 12 physics, different concepts, different devices such as resistors, diodes, transistors, then capacitors, inductors, if you try to fabricate all of them in a simple circuit, in a single block of circuit, which is also called as chip, this complete device or this complete circuit is called as integrated circuit, and that is basically what is the meaning of your IC. Okay. The most widely used technology is the monolithic integrated circuit, that is MIC. The word monolithic is a combination of two Greek words, first is monos, which is single, and second is lithos, which is stone. This in effect means that the entire circuit is formed on a single silicon crystal. So, everything is formed on a single silicon crystal or chip. The chip dimensions are as small as 1 mm cross 1 mm. So, you can see what is the size of this chip. They are very small chips. The chip dimensions are as small as 1 mm cross 1 mm, or it could be even smaller. Figure shows a chip. So, you can see this is the figure, shows a chip in its protective plastic case, partly removed to reveal the connections. coming out of the chip to the pins that enable it to make external connections. So, you can see this is a small chip, this is a plastic case, so that we need to protect it. Then there are connections made from chip to the pin, and these pins are basically attached to the, let us say, motherboard. Okay, it is a notch, small dot. So, these are basically pins. Pin dimension, you can also see the pin dimension, it is very small, it is 2.5 mm only. Fine. So, depending on the nature of the input signals, ICs can be grouped into two categories. Okay. So, first is the linear on the analog ICs, and second digital ICs, similar to the digital electronics which we made. So, first was regarding your analog signal and second was regarding your digital signal. So, let us understand whatever is written here. So, the linear ICs process analog signals which change smoothly and continuously over a range of values between a maximum and a minimum. So, what does it mean by linear IC? A linear ICs process analog signals. So, what does it do? It processes analog signals, please quite evident, it is a linear analog IC. So, it will produce analog signal only. A digital IC will produce digital signal. So, the linear ICs process analog signals which change smoothly and continuously over a range of values. So, it basically has a variation in the values over a range of values which between a maximum and a minimum. The output is more or less directly proportional to the input, that is, it varies linearly with the input, and that is why they are also called as linear ICs. Okay. One of the most useful linear ICs is the operational amplifier. The digital ICs process signals that have only two values. So, digital IC quite evident, we have understood in the digital electronics also that they have only two inputs, one is 0, one is 1. So, similarly, digital ICs will also have only two values. They contain circuits. So, digital ICs process signals that have only two values. So, the processed signal will have either the value of 0 or have the value of 1. They contain circuits such as logic gates depending upon the level of integration. So, what does it mean by level of integration here? So, that is the number of circuit components or logic gates. The ICs are termed as small scale integration SSI, which is logic gates less than 10, medium scale integration MSI, logic gates less than 100, large scale integration LSI, logic gates less than 1000, and very large scale integration, that is VLSI, which is logic gates greater than 1000. Okay. VLSI is the major topic of understanding in higher studies also. So, generally all the different devices which we generally work upon uses VLSI. I will not go into detailing of that. So, basically you can understand if you go on with understanding of electrical engineering in your subsequent years, then you will understand that VLSI has a major role in many of the industries, many of the devices. The technology of fabrication is very involved, but the large scale industrial production has made them very inexpensive. Fine. So, that is the complete ending of your semiconductor electronics, materials, devices and simple circuits. Let us do a quick summary and then we can close the lecture. Okay. So, semiconductors are the basic materials used in the present solid state electronic devices like diodes, transistors, IC. So, now we know what is a diode, we know what is a transistor, we know what is an IC. ICs are basically integrated chips, integrated circuits. Lattice structures and the atomic structure of constituent elements decides whether a particular material will be insulator, metal or semiconductor. So, we understood the band theory of solids, we understood basically what is the conduction band, difference between conduction band and valence band. Depending upon that scenario, we can understand that whether the material will be an insulator or a conductor or a semiconductor. Metals have low resistivity, insulators have very high resistivity, while semiconductors have intermediate value of resistivity, and that is how also we can say that its name is got upon, it got its name. Semiconductors are elemental. So, basically the purest form or the basic applications or basic generally used semiconductors are basically silicon and germanium as well as compound. So, they are formed in compound also, but generally in the understanding we generally use it for, or we generally use silicon and germanium for understanding. Pure semiconductors are called as intrinsic semiconductors, the presence of charge carriers. So, we also understood the complete analogy of what are electrons, what are holes, how are charge carriers being formed upon, how electrons goes from one side to another side, how holes go from one side to another side, etc. The presence of charge carriers, electrons and holes is an intrinsic property of the material, and these are obtained as a result of thermal excitation. So, basically an energy is being provided to it, because of that energy being provided, it has that energy inside it Therefore, depending upon the difference between the conduction band and the valence band, it can excite or basically jump from the valence band to the conduction band. Okay. So, the number of electrons Ne is equal to the number of holes in intrinsic conductors, but that is not the case in your extrinsic semiconductors. Holes are essentially electron vacancies with an effective positive charge. So, electrons are having negative charge, holes are having positive charge. The number of charge carriers can be changed by doping of a suitable impurity in pure semiconductors. So, depending upon the doping, if it is a positive doping or it is a negative doping, p type and n type semiconductor respectively are being named. Such semiconductors are known as extrinsic semiconductors. There are two types, n type and p type. In n type, n is greater than very greater than nh, while in p type nh is very greater than ne. So, we also understood as n name is given, n is negative. So, how we can remember as in which type of carrier has major which carrier is majority there. So, in n type Ne as n is word is used. So, we can say it is electron negative, and similarly for p it is positive. So, it can be said resemble it to holes. So, n type semiconductor silicon or germanium is obtained by doping with pentavalent atoms like arsenic, Sb, etc., lead, etc., while p type silicon or germanium can be obtained by doping with trivalent atoms, acceptors like boron, aluminum, iridium, etc. Ne into nh is equal to Ni square in all cases. Further, the material possesses an overall charge neutrality. Next thing is about the conduction band and the valence band. So, there are two distinct bands of energies called the valence band and the conduction band, in which the electrons in the material lie. Valence band energies are low as compared to conduction band energies. All energy levels in the valence band are filled, while energy levels in the conduction band may be empty or partially filled, and that is why there is a excitation being happening. The electrons in the conduction band are free to move in a solid and are responsible for the conductivity. The extent of conductivity depends upon the energy gap, and that is how we can say that a material is a material is conductor, insulator or semiconductor. Between the top of the valence band EV and the bottom of the conduction band EC. So, here it is EC and this is your EV. Okay. The electrons from the valence band can be excited by heat, light or electrical energy to the conduction band, and thus produce a charge in the current flowing in a semiconductor. For insulators, Eg is greater than 3 electron volts. For semiconductor, it is 0.23 electron volt to 3 electron volts, but for metals, it is approximately 0. In some case scenario, even the conduction band and the valence band are overlapped on each other. PN junction is the key to all semiconductor devices. When such a junction is made, a depletion layer is formed. So, we have understood these concepts when we are understanding PN junctions. So, a depletion layer is formed consisting of immobile ion cores devoid of the electrons or holes. This is responsible for a junction potential barrier. So, that thing being said, next thing is regarding by changing the external applied voltage, junction barriers can be changed. Understood the forward bias, what does it mean by forward bias? N side is connected to negative, and similarly P side is of the battery and P side is connected to the positive. The barrier is decreased while the barrier increases in reverse bias. Reverse bias is basically that a P side is connected to a negative terminal. Hence, forward bias current is more, which is milliamperes, and it is very small in a PN junction diode. Okay. Reverse bias is very small and forward bias is in milliamperes. So, diode can be used for rectifying an AC voltage. So, full wave rectifier, half wave rectifier were being understood. So, restricting the AC voltage in one direction with the help of a capacitor or a suitable filter, a DC voltage can be obtained. There are some special purpose diodes. So, we understood that diodes also, one was Zener diodes, then photodiode, then light emitting diode, or in light emitting diode was a part of photodiodes only, and then we understood about solar diodes or solar cells. The next was regarding our transistors. So, in transistors we understood that transistor can be an NPN or a PNP device. The central block, so we understood the doping also and the thick or thin level of them also. We understood basically logically as in why something is thin, why something is thick, etc. The central block thin and lightly doped is called base, while the other electrodes are emitter and collectors. The emitter based junction is forward biased, while the collector based junction is reverse biased. Please remember this is very important. You need to remember this. The emitter based junction is forward biased, while the collector based junction is reverse biased. The transistors can be connected in such a manner that either C or E or B is common to both the input and output. In our case scenario in 12th class physics, we have generally took the configuration of CE only. This gives the three configurations in which a transistor is used: common emitter, common collector and common base. The plot between IC and VCE is fixed, IB is called output characteristics, while the plot between IB and VBE with fixed VCE is called as input characteristics. These all things are being understood. We understood different graphs also for input characteristics, for output characteristics, etc., when we were understanding transistors. The important transistor parameters for CE configuration are input resistance, output resistance and current amplification factor. We understood basically what is the meaning of input resistance, how can we, what is basically beta AC, what is basically beta DC, etc., were being understood when we were understanding transistors. So, transistors can be used as an amplifier and an oscillator. We understood the complete functioning of amplifier also. We understood why the output obtained is amplified also, and it is 180° out of phase also. We understood the complete working of oscillator. In fact, an oscillator can also be considered as a self sustained amplifier. We understood what is the meaning of self sustained amplifier. So, it basically does not need any input again and again, in which a part of output is fed back to the input in the same phase, which is positive feedback. We understood the feedback mechanism also there in the oscillator. Next thing is regarding voltage gain. The voltage gain of a transistor amplifier is common emitter configuration is AV. Okay. So, this also we understood there. So, we also understood small scale current gain, small scale voltage gain. So, when the transistor is used, we understood small scale voltage gain, in understanding about the amplifier. So, when the transistor is used in the cutoff or saturation state, it acts as switch, very important, and when the transistor is used in active state, it is used as an amplifier. So, next thing is that there are some special circuits which handle the digital data consisting of 0 and 1 levels. They are basically digital electronics. This forms the subject of digital electronics. The important digital circuits performing special logic operations are called as logic gates. They are OR, AND, NOT, NAND and NOR gates. In modern day circuits, many logical gates or circuits are integrated in one single chip. They are known as integrated circuits. Okay. So, basically just understanding again what are these gates. So, what is NOT basically? If 1 is the output, you will get 0. If 0, then it is 1. What is OR basically? If 0 0 0 1 1 0 1 1. So, it is 0 1 1 1. What is for AND gate? AND gate is again 0 0 0 1 1 0 1 1. So, it is only 1 here, rest all are 0. What for a NOR gate? NOR gate, the output will be 0 0 0 1 1 0 1 1. It will be just opposite to an OR gate. And what will be for a NAND gate? So, 0 0 0 1 1 0 1 1, it will be just opposite to a AND gate. Okay. So, that is how these all things are being done. That was a complete summary, that is the complete ending of the lecture series on semiconductor electronics, materials, devices and simple circuits. Every concept has been looked upon. I think as far as NCERT is concerned, I have explained everything. I tried to use some pictures also. I tried to explain everything. Just keep on revising all these concepts. Please understand forward biasing, reverse biasing at a much greater detail. Understand all the different ways in which the transistors are being utilized. Understand the complete analogy as in how we got the out of phase mechanism for an amplifier, etc. Logic gates are very important. In exams questions can be asked directly regarding all these gates. And finally, just a simple understanding of different types of integrated circuit, that is analog ICs and digital ICs should be understood or should be known by the student. So, that thing being said, let me stop the discussion here. So, just the course progress, final course progress. We started with introduction. Then we went to classification of metals, conductors and semiconductors. Then we went to intrinsic semiconductor, the purest form. Then extrinsic semiconductor, in which doping is used. Then p-n junction, in which depletion region is formed. Semiconductor diodes have been explained. The next was application of xenodiode as a rectifier. So, full wave rectifier, half wave rectifier, etc. were being utilized, explained there. Next was special purpose p-n junction diodes, in which we understood xenodiode, photodiode, solar cells, etc. Then we understood junction transistors, we understood elements such as base, collector, emitter, common emitter and concept were utilized there. We understood applications of junction transistors such as amplifier, switch, oscillator. We also understood feedback mechanism. We also understood what is positive feedback, what is negative feedback. So, when it is in phase, it is called as positive feedback. When the input, which is part of the output, is being acted upon, which is same as the initial input, or which is in phase with the initial input, it is called as positive feedback, and if it is out of phase, then it is called as a negative feedback. Then we understood digital electronics, logic gates also, all the 5 gates, and then finally we understood a simple understanding or fact topic about integrated circuits. Fine. So, that thing being said, let me stop the discussion here. Thank you very much.